Hi everyone, this is a video about mitochondria and antibiotics and whether antibiotics are harmful for the mitochondria in some way, shape, or form. Um, I someone asked a Someone asked this question on one of my other videos, just saying apparently during that video I said something about antibiotics being potentially harmful for mitochondria, and she was wondering where that statement came from. So fair question, and the question or the statement, whatever the specifics were that I mentioned there, came from some research that I did. I put together a training course for other clinicians on mitochondrial dysfunction, and just really took a deep dive down the rabbit hole of looking at the research literature as it relates to mitochondrial function and dysfunction, and so it's something that I'm quite well versed in. So I just brought up my slides for my course that I put together there. So I'm going to tell you straight from the research literature horse's mouth. So there is a PubMed article. It's a PubMed Central article, no less, meaning full free text is available. The PMC ID is 376000005, and so straight from that study, it says clinically relevant doses of bactericidal antibiotics such as quinolones, aminoglycosides, and beta-lactams cause mitochondrial dysfunction and reactive oxygen species, which are pro-oxidants, the kind of the opposite of antioxidants, which we certainly don't want in excess in our cells. So they cause mitochondrial dysfunction and reactive oxygen species overproduction in mammalian cells. Further direct quotes from this study, various antibiotics lead to oxidative damage to DNA, proteins, and membrane lipids. They also reduced the function of complex 1, which is one of our complexes in our electron transport chain, a key part of our mitochondria. The function was 16 to 25% less, and also complex 3, which is 40% less function. Now, this is in cell lines. Of course, there's no way, to my understanding, that they've been able to actually directly test, the function of mitochondrial electron transport chain. Sorry, folks, trying to make a fast video. I'm in a rush, and it's been a long day, so excuse the less than articulate speech here. There's no way to test this directly in human subjects, but they did find that these cell line studies, this is something that happened. Just some further information from this study. Mice treated with bactericidal antibiotics. Why do they say bactericidal antibiotics? Like, isn't that kind of built into the name, antibiotic? But anyways, they exhibited elevated oxidative stress markers in the blood, oxidative tissue damage, and upregulated expression of key genes involved in antioxidant defense mechanisms. And then also of note from this study that they found that in vitro and also in vivo in mice, they found that giving N-acetylcysteine, NAC, mitigated the antibiotic-induced damage, but had no negative impact on the bactericidal activity from those antibiotics. So kind of cool that maybe protect the mitochondria by taking NAC. Yet another reason to take NAC. As per usual, nothing I'm saying should be construed as medical advice. This is for informational purposes only. Please talk to your healthcare provider for medical advice, including advice around taking NAC or not taking NAC. The punchline here, or I guess what really matters here, though, is like, well, what do we take as a punchline from this? Like, yeah, so there is some evidence that antibiotics are not so good for the mitochondria. Why might that be? Interestingly enough, when you look at the origins of life on this planet, like biological life on this planet, then ultimately the prevailing theory is that we as sort of single-celled organisms once upon a time created this symbiotic relationship where bacteria started living inside of us as single-celled organisms, and we kind of we gave the benefit to the bacteria, protecting them with our wonderful cell membranes and various other resources, and then the bacteria gave us benefits by letting our single cells use the various compounds that are produced by the bacteria, and over time those bacteria ultimately morphed into what we now know as modern day mitochondria. So that's this prevailing theory. There's a name for that theory, and I can't remember what it's called now, but anyways, that's the prevailing theory. So it's not a big surprise then that antibiotics, which are antibacterial, they are anti-mitochondria. But what does that mean to us in day-to-day life? Well, does that mean like, oh, we should be thinking twice before taking an antibiotic for this or that therapy? Well, if it that ultimately comes down to being a cost-benefit ratio for the individual in question, how serious the bacterial infection might be that they're dealing with, life-threatening pneumonia versus I'm just feeling the initial hints of urinary tract infection. those are totally different scenarios. So of course antibiotics are, I think they're a fantastic innovation. I think that they can be very useful. They're life-saving in many cases. I think it's a wonderful therapy, but it is important. I think it's of relevance, I should say, to note that they're maybe not the best for our mitochondria. And folks listening who might be in the midst of long-term multiple antibiotic therapy for their chronic Lyme disease or other chronic bacterial infections, might be thinking like, oh, like, do I want to be doing this to my mitochondria? And to which I would say, if a patient was in my office, they're on antibiotics, they're like, oh man, like I just listened to this video, like should I keep taking these antibiotics? At the end of the day, if antibiotics are helping someone, then it's probably a good thing to consider continuing to use those, but it would be also worth considering working with things to help support the mitochondria at the same time. Maybe things like NAC based on this, limited research data that's available, but also maybe some other mitochondrial supports as well over and above that, which I've talked about in other videos, and have a whole free lecture about that. If you subscribe to my newsletter, then the second module of my Overcoming Chronic Illness course, which is free to anyone who subscribes to my newsletter, gets into that in explicit detail. There is additional research literature around about the impact of specifically fluoroquinolones having a negative impact on mitochondrial function. Let me see here. There is a study called treatment of the fluoroquinolone associated disability, the pathobiochemical implications. And I don't have the PubMed ID handy here, but it goes into explicit detail in terms of how fluoroquinolones, drugs like sorry folks, not Cipralex, no, it's a different one. Anyways, fluoroquinolone drugs. Sorry again, folks. Yeah, not the most articulate today. Anyways, fluoroquinolone antibiotics can have, oh my gosh, it's really gonna bug me now. Can't think of it off the top of my head. I'm gonna think of it as soon as I hit stop on this video. Anyways, they can be particularly harmful for the to the mitochondria, which is why some folks get what they call flocks, where they take these various medications and they can have extreme mitochondrial disability afterwards. It's very rare to see that, but it does happen sometimes, and it's really quite the rigmarole trying to get those folks better. But it's doable, but it can be quite the process. So ciprofloxacin, that's the one I'm thinking of. Ciprofloxacin and moxifloxacin and levofloxacin. There we go. I knew it was in there somewhere. So anyways, I will leave it there before I misspeak something else here. Thank you for the question. I hope that answered your question. If anybody has any further questions or comments on this topic or anything else, please post in the comment section below, and I will leave it there for now.